Bonsuelo mathletes. Okay, kind of a little, I don't know if I'd call this a diversion or a sidetrack, because you need to know this in order to do what we're going to be doing. But I'm going to introduce a whole new type of number called imaginary numbers. Now you could go, well, if they're just imaginary, what do we need to know them for? Well, they're not imaginary in the sense of they're a figment of my imagination. They just don't fit the definition of every type of number you've dealt with before, which are called real numbers. Okay? So we'll talk about imaginary numbers in a little bit. But first of all, I want to talk about something we haven't really talked about this year, and that's rationalizing a denominator. Making a denominator not have a radical over it. Okay, making it a rational number. First of all, you don't want to do this unless you have to. So in other words, take a look at these problems. Can I take the square root of 49 and the square root of 81? Yes. So do so. Okay, that's fine. Can I take the square root of 12 and the square root of 3? Well, not really, but I can take the square root of 12, but I can cancel at least. Remember, you can't cancel the radicals. You can only cancel the numbers under the radicals. But 3 goes into 12 4 times. So you have the square root of 4 of the square root of 1. Square root of 4 is 2, and the square root of 1 is 1. So that simplifies into 2. Okay, same thing here. You can take the square root of the 45, but you can cancel the 5 and the 45. And then take the square root of 1 and the square root of 9. Okay, so far so good. All right. Well, I can cancel here. 3 goes into 21 7 times. Square root of 1 is 1, but the square root of 7 is just square root of 7. So that presents a problem. For reasons I'm not going to go into, you may not leave a radical over the denominator. Okay? So this is what we're going to do. I know this is going to sound weird, and it's going to seem like I'm making it more complicated than it needs to be, but I think you need to understand this. Okay? So I'm going to write something down here. Don't write it. Okay. What's the index there? The index is 2. All right. It's not written. Doesn't need to be written, but it's implied if it's not written. Okay. Well, what does the exponent here have to be before I can take its square root? What's the smallest number that can be, the exponent can be, that I can take its square root? And hopefully you realize it's the square, because the square root of x squared is just x. It's not entirely true. It's actually the absolute value of x, but I'm not going to get into that. Okay? Well, how about if it's this? How about if I tell you it's and again, don't write any of these down. What if it's a fifth root? What's the smallest number that can be in the exponent that before I can take out the quantity from another radical? A 5, because the fifth root of x to the fifth would be x. Okay? Well, what if it was, 17? Let's go for 17. Well, then this would have to be x to the 17th. The 17th root of x to the 17th is x. Okay. So, what I want to be able to do is take this 7 out from under the radical. So what do I want its exponent to be? I want its exponent to be 2. I want it to be the square root of 7 squared. Well, what can I multiply it by to get it to be 7 squared? Well, right now it's 7 to the first power, even though that one's not written. Okay? So I've got a single 7. I need another one. So what I'm going to do is I have to multiply the top and bottom by the square root of 7. Now, something I want to point out, you can't multiply by square root of 7. I didn't multiply by square root of 7. This is not an equation. You can't change the value of the fraction. The only thing you can multiply by is 1. It's kind of like this. I'm going to scribble something else down here. Okay, common denominator for this is 6. Well, what do you multiply this first fraction here, well, the 1/2, by to get a denominator of 6, and it's not 3. Okay, 3 times 1/2 is 3/2. Okay, you have to multiply by something over itself, because the only thing you can multiply by and not change the value of the number is 1, and 3 over 3 is equal to 1. That's why it's 3/6. What do you multiply 1/3 by to get a denominator of 6? Not 2, but 2/2, which is equivalent to 1. Okay? That's how you add fractions. And don't let anyone else teach you some sort of lame shortcut, because it's going to kill you. All right? So the reason why I'm mentioning this is that the same goes here. You can't just multiply by square root of 7, because it's not an equation. Remember, everything's either equations or not equations. This is not an equation. So the only thing you can multiply by and not change it is 1. So we're going to multiply by the square root of 7 over the square root of 7. And what does that give us? Well, the square root of 7 times 1 is the square root of 7. And square root of 7 times square root of 7 is, I'm going to show a step you'd never need to show me, is the square root of 7 squared, which then just turns into 7. Okay? This should just be review, by the way. Okay, number 5, you can't cancel anything. By the way, why didn't I do that in like numbers 1 through 3? I didn't need to. Remember, try and simplify first. Simplify and then rationalize if you need to. I simplified number 1, I was done. Simplified number 2, I was done. Simplified number 3, I was done. I simplified number 4, but I wasn't done because there was a radical in the denominator, so I had to deal with it. Okay, let's take a look at number 5. Let's take the square root of the top, square root of the bottom. I've simplified. Is there a radical in the bottom? Yes. So I'm going to multiply by square root of 3 over square root of 3. So you get square root of 3, and on the bottom you get 3. Okay, number 6. By the way, a lot of people are going to do this, and it's going to kill you. Okay? They go, oh, forget all that. Just rationalize it. Square root of 3 over square root of 3. Okay? No, don't do that. I know it kind of seems to work, but it doesn't. Okay, so it's 1 over square root of 3. Then we rationalize it. So you got to simplify it before you try and rationalize it. And again, by rationalizing, I just mean getting the radical out of the denominator. Okay, see what a lot of people do here, which is wrong, is they multiply by square root of 12 over square root of 12. Oh, that's not correct. Okay, you simplify first and then rationalize. So the square root of 1 is 1, square root of 12 is 2 square root of 3. Okay, now, let's get the radical out of the denominator. Do I have to get the 2 out of the denominator? No, the 2's not a problem, just the square root of 3. So I multiply top and bottom by square root of 3. Square root of 3 times 1 is just square root of 3. And now the square root of 3 times square root of 3 is 3 times the 2 that's there. I'm going to write something you'd never need to write. And then the square root of 3 times square root of 3 is 3. So we get square root of 3 over 6. And you should go straight from this to that. Just like here, you should go straight from this to that. Okay? All right, let's take a look at this. Again, take the square root of the top. Take the square root of the bottom, and the square root of 18 is 9 times 2 is 18. So the square root of 9 is 3, the square root of 2 is just square root of 2, and then multiply top and bottom by square root of 2. So we get square root of 10 all over, square root of 2 times square root of 2 is 2, times 3 is 6. Okay, now, here's a problem. See, if you look at number 7, the 3 is not a problem. Another thing that's a problem is the square root of 2. And number 8, I guess I could say the 3 is not a problem there either. It's the square root of 2, but there's an additional difficulty here, and that's this plus sign. Okay? So what I'm going to do is show you what to do, because, well, first of all, I'm going to show you what not to do. Do not multiply by square root of 2 over square root of 2. Why? Because you get square root of 10, and when you distribute the square root of 2 on the bottom, you get 3 square root of 2 plus 2. Well, that doesn't get rid of the square root. Okay, so that's not going to work when you have a plus down there. Okay, so what are we going to do? I'm going to show you something. Don't write it down. How do you factor x squared minus y squared? Factors in x minus y times x plus y. Notice there's no middle term. When you have something minus something, and then the other factor is the same first thing plus the same second thing. That's going to give us no middle term. These things are called conjugates, which I don't care if you really know that. You just need to know what they are. Okay? So if I ask you, what's the conjugate of, k plus z? You'd tell me the conjugate, don't write any of this down, just listen. The conjugate is k minus z. If I multiply that together, I won't get any middle term. What if I tell you, I don't know, 3 minus x? What's the conjugate? 3 plus x. If I multiply that together, I won't get any middle term. All right, well, so what are we doing here? In order to rationalize this, we need to multiply by the conjugate of the bottom. So since this is 3 plus square root of 2, we're going to multiply by 3 minus square root of 2 on the top and bottom. Okay, so let's distribute. Square root of 5 times 3 is 3 square root of 5. Square root of 5 times square root of 2 is minus square root of 10. Then on the bottom, we'll distribute. 3 times 3 is 9. 3 times negative square root of 2 is negative 3 square root of 2. Then square root of 2 times 3. It's just distributive property plus 3 square root of 2. And then minus 2. And notice what happens. These two things, they don't cancel, by the way. They subtract. So we get 3 square root of 5. Let me get rid of that line so it's not confusing you. Minus square root of 10 all over 7. Okay? Here we'd multiply by 4 plus square root of 11. Okay, so it would be 4 square root of 7 plus square root of 77 all over 4 times 4 is 16 plus 4 square root of 11 minus 4 square root of 11 minus 11. So it's 4 square root of 7 plus square root of 77 all over 16 minus 11, which is 5. Okay? All right. That's all introduction. So numbers 1 through 3 are review. Numbers 4 through 9 are how to rationalize. And make sure you understand that before you go on. Okay, here we go. What are imaginary numbers? Let's take these roots. Okay, what number times itself will give you 25? 5, period. Remember, nothing else. What number times itself will give you negative 25? So far, nothing. You can't do it. We'll change that in about 3 minutes. What times itself 3 times gives you 8? 2. What times itself 3 times gives you negative 8? Negative 2. So the only thing you couldn't do is if it was an even index, a square of a negative, square root, fourth root, fifth root, sixth root, et cetera, et cetera. Okay, I'm going to give you a new definition that's now going to allow us to do this second problem. And that's the square root of negative 1 equals I. Now, I have to point out something. I, which is a letter, is not a variable. It represents square root of negative 1. And if I ask you to simplify, don't give me square root of negative 1. I is the simplified form. Okay, so how do you do this? And I'm not going to get into why we do this. I'm just going to make sure you can make the calculation. Okay, just one more thing I want to tell you is notice that if we take this statement, negative square root of negative 1 equals I, and we square both sides, we get this. Okay, so you should know that also. So the two things you should know are square root of negative 1 equals I, where this is the simplified form. And negative 1 equals I squared, where this is the simplified form. All right, so what are we going to do? Remember, your first thought, or should be your first thought, when you take a root of any kind, square root, cube root, eighth root, whatever, is factor. Okay, so what I'm going to do is I'm going to factor negative 25 into negative 1 times 25. And then what's the square root of the negative 1? It's I, and the square root of 25 is just 5, so it's 5I. And again, why we do this, I'm not going to get into today. Okay? I want to point out, all you really need to do is this. Take the square root of the negative out and make it I, and then take the square root of the 25 and make it 5. You don't need to do all this stuff in the middle. Okay? It's just kind of the long technical way of doing it. Okay. I want to point out something. All rules with radicals only apply when you have real numbers, okay? So I'm going to show you something real quick that you have to be careful of. What's the square root of 2 times the square root of 2? Well, hopefully you know the answer is 2, okay, fine. But and that'd be fine. You could just tell me that. But if we're going to do this the long, technically correct way, we'd multiply the 2 and 2 to get 4, and then the square root of 4 is 2. Okay, may I do the same thing here? Negative times 2 times negative 2 is 4. No, you can't. Why? Because these are not real numbers. You can't do anything until you take that negative out from the radical and make it I. So what I'm going to do is take the square root of negative 2. And I'll take the square root of the negative, and then the square root of 2 I can't do anything with. Okay. By the way, some people write it like this, and often Alex does. I don't particularly care for that. Most of the time it's probably okay if you do that. The reason why people do this is so then they don't make this line like this is what some people do by accident. They go square root of 2, and they put the I underneath the radical. The I is not underneath the radical. Remember, once you perform an operation, okay, the operation goes away. So when you take the square root of the negative, it's an I outside of the radical, and only the 2 is left under the radical because we haven't taken its square root yet. Okay, so the square root of the first one is square root of 2 times I. Second one is the square root of 2 times I. Okay, now let's combine what we can. Now we can combine the 2's because they're written as real numbers. So square root of 2 times square root of 2 is square root of 4, and I times I is I squared. Okay, what's the square root of 4? 2. And what's I squared? Remember up here, we said I squared is negative 1. So it's 2 times negative 1, which is negative 2. Okay? Now, I can't emphasize enough. You have to take the I out first. And after you take the I out, you can pretty much do everything you've done in the past, just with the radicals. So and why we're doing this, I'm not even going to get into today. Okay? All right. So what would the square root of negative 12 be? Well, first of all, you got to take out the square root of the negative and make it I. And then what's the square root of 12? 2 square root of 3 with the I. And again, some people are going to write this. That's fine. It's not that big of a deal. Just recognize I don't write it that way. The I is not under the radical. Okay? All right, here. Can we do anything? No, we can't cancel. Why not? Because there's a negative under the radical. So we have the square root of the negative is I. And the square root of 12 is just the square root of 12. Yeah, we could take the square root of 12. Now may I cancel? Yeah, because the negative isn't under the radical anymore. So square root of 3 cancels with the square root of 12 to give you square root of 4 times I over the square root of 1. So this ends up like this. You don't have to write this, but So that's the square root of 4 is 2. Square root of 1 is just 1, so it's just in the denominator. So you can go straight to this. So after you pull that I out, you can cancel the 3 and the 3 and the 12. Okay, here, may I multiply the 5 and the 10? No, you may not, because they have i's, negatives under them, under the radicals. So we have square root of 5 times I and square root of 10 times I. Now we can multiply the 5 and the 10. So that gives us a 5, and if we factor 10, it's 5 times 2. And then I times I is I squared. Well, let's take the square root of the 5 times 5 is 5. Square root of 2 is just square root of 2. And now what's this I squared? It's negative 1. Okay? And then that's negative 5 square root of 2. Remember up here, the square root of negative 1 is I, but I squared is negative 1. And I know I'm going through this pretty quickly. Okay? Now, what is there to do here? Is there a radical? Yes, there is. That I is number 3. That I is a radical. Doesn't look like a radical, but remember, the I represents a number that contains a radical. So just like we rationalized up here by multiplying, where is it? Like square root of 7 over square root of 7, we'll do the same thing here. We're going to multiply by I over I. And what does that give us? 5I over 3I squared. And what's the I squared on the bottom? A negative 3. So we have 5I over 3 times negative 1. And you can remember, I hope you realize this, negative 2 over 3 is the same thing as 2 over negative 3, which is the same thing as negative 2/3. Okay, those are all three the same thing. So as opposed to leaving the negative in the denominator, it's just a little more convenient to write it negative 5/3 I. Or you could write you could write negative 5I over 3. That'd be fine too. Because remember, this I, the way it's written, would be in the numerator. Okay? It's kind of like saying this. 3/7 x. Don't write this down. Where's the x? If I want to think of it as in the numerator and denominator, that's like saying 3/7 times x over 1. So that's like 3x over 7. Okay. Myself, I usually write it like this, and that's kind of the standard way to write it. But okay, here, what can I do? Take the square root of 4. Now, I'm going to do this in one step because it just gets tedious. I'm not going to pull out the negative as a separate step. So what's the square root of the negative? I. And what's the square root of 9/3? Again, the problem is not the 3. The problem is the I, so I'm going to multiply by I over I. Again, let's shorten this up a little bit. So on the bottom, we get negative 3. And I'm just going to put the negative with the whole fraction. And if you put the I in the numerator with the 2, that's fine. Okay, here, number 5. We have the square root of negative 12. What's the square root of negative 12? Well, the I is the negative, and 2 square root of 3 is the square root of 12. Okay, well, the 2's not the problem, but both the square root of 3 and the I are the problem. So we're going to multiply top and bottom by square root of 3I. Okay? And again, the I is outside the radical. So let's see what you get on the top. You get 3 square root of 3I. Fine. On the bottom one, you get 2. Well, square root of 3 times square root of 3 is 3. And I times I is I squared, which is negative 1. So you end up getting negative 3 square root of 3 all over 6I. But notice what happens is I can cancel the 3 and the 6. So ultimately, I get negative square root of 3 all over 2i. Okay, well, remember when you rationalize and there's a plus sign, it's not as simple as just multiplying top and bottom by I. We have to multiply by the conjugate, and the conjugate would be 3 minus 2i, all over 3 minus 2i. And then it's just a matter of multiplying it out. So we have 21 minus 14i all over 3 times 3 is 9 times negative 2i is negative 6i, then 2i and 3i is plus 6i, and then minus 4i squared. Okay, now here's where you got to be careful. Okay, so fine, these go away, right? But look at this. That's the same thing as a plus 4, right? Minus 4 times negative 1. So that's 9 plus 4, which is 13, right? Because we're going to combine the 9, and the minus 4i squared is the same as plus 4. So 9 plus 4 is 13. Okay, here, we're going to take 8 plus square root of 7i. That's the conjugate of it. And now it's just tedious multiplication. So we distribute the 5, and we get 40 plus 5 square root of 7i. And again, the i's outside the radical. And then we get 8 times 8 is 64 plus 8 square root of 7i minus 8 square root of 7i. And then you got to be really careful here. What's the square root of 7 times the square root of 7? It's just 7, okay? It's not 49. It's the square root of 49, which is 7, and then 7i squared. And again, what's this 7i squared? The 7i squared is plus 7. So we have 40 plus 5 square root of 7i all over. These go away, and we combine the 64 with the plus 7, and we get 71. Okay, last one here. Conjugate would be 5 minus 4i all over 5 minus 4i. Now it's just tedious multiplication. So, and it's just, just distribute a property. 2 times 5 is 10. 2 times negative 4i is negative 8i. Then then we'll distribute the I. It gives me plus 5i and minus 4i squared. It's on the top. On the bottom, we get 5 times 5 is 25. Then minus 20i plus 20i and minus 16i squared. So what happens? On the top, the 10 and the plus 4, negative 4i squared is plus 4, combined to give us 14. And then negative 8i plus 5i is minus 3i. Okay, on the bottom, the 25 and the plus 16, because minus 16i squared is plus 16, combine to give you 41. Okay? So there's a lot there. I went through it pretty quickly because if you understand it, I don't want to drag it out. But if, you may need to listen to a few of these and certainly ask me questions. Okay? Last thing I want to do. If you're asked to write something as a single number, as a complex number in standard form, you have to separate it into the real part that doesn't have the I and the imaginary part. So for instance, let's take a look up here in number 6, 7, and 8. None of those are in standard form. Okay? They kind of have the X and the real and the imaginary part together. So like here, 12 minus 7i all over 5. To write it in standard form, we must separate it into 12/5 minus 7/5 I. Because I can give, just a quick review, x plus y over 7, or whatever, let's say z. I can call that x over z plus y over z. Okay. Now, the opposite's not true. If I have z all over x plus y, can I split that up? No, I can't. Right? It's only if the plus is in the numerator. And, that's just basic math. So you should know that. I just thought I'd mention it. Okay? So let's do a couple more problems and write in standard form. Okay, so this is just simple subtraction. 2 minus 6 is -4. -5 minus 4i is -9i. That's in standard form, no problem. Remember, you can't distribute a square. Why not? Because of the minus sign, so we have to take 5 minus 2i times 5 minus 2i. So that gives us 25 minus 10i minus 10i, and then plus 4i squared. So we're going to combine the 25 and the minus 4, which is plus 4i squared, into 21 and then minus 20i. Okay? Last one. Let's rationalize it. So we have 8 minus I over 8 minus I. Okay, so we get whatever 13 times 8 is. What's that? 80. 80 and 24 would be 104. Minus 13i. That's the top. And the bottom's going to be 64 minus I squared. I kind of took a little shortcut there I probably shouldn't have taken. Okay, so we have 64 minus 8i plus 8i, and then minus I squared. Okay, well, that minus I squared is plus 1. So we have 104 minus 13i all over 65. Okay? Now, something kind of weird about this one is this, well, it's not weird. I asked you to write it in standard form. So we have 104 over 65 minus 13 over 65i. Now, okay, now I guess you could say it's kind of, I don't know if this is weird, but you can cancel each fraction. I think the most obvious one, I hope it's obvious, is the 13 and the 65. Okay, 13 goes into 13 once, and 13 goes into 65 5 times. 13 goes into 104 8 times. And into 65 5 times. I'm not so much concerned with the canceling, although you should be able to do that. But you should know how to split it up, if I ask for it, or if Alex asks for it, into standard form. Okay? So there's a lot there. We started off with rationalizing denominators, and then we defined imaginary numbers and just took a look at calculations. What these are used for is a little bit beyond this class right now. When you get to pre-calculus, you'll learn more about what they're really used for. And then when you get to calculus, you'll really learn what they're used for. My job is just to make sure you can make calculations with them. Okay? But don't get the idea that they're not, they don't exist. They do exist. They're just not what fits the technical definition of a real number. That's all. Okay? So, ask away. Ask questions, please. Have a good day, everybody.